Today we're taking a look at sections 3-1 and 3-2 on measures of center. Our learning outcomes will be the following. Determine the mean, median, mode, and mid-range from a given set of data. Determine the mean for data listed in a frequency table. Determine a weighted mean, and determine which measure of center is most representative of a given set of data. Okay, so first we're looking at the different measures of center, and we have 4 of those that we'll be talking about. The first one is the most common one, sometimes just called the mean or the average. It's the arithmetic mean. And what we do with the arithmetic mean is we add all the values we have together and divide by the number of values. So what you will see here is a formula for the sample mean, and this one has a symbol. It's called the summation symbol, which simply means to add up all the values. So here it says sum up all the x's and divide. N is the number of x's or the number of values. Lowercase n is used for samples, and uppercase N is used for populations. And if we're working with a population mean, the formula is very much the same. It's the sum of the x's, and those are all the values. We add up all the values and divide by the number of values. So you can see a capital N indicates the number of values in the population. And so again, this one is called an X bar. And mu is a Greek letter that's used to represent the population mean. Now I have 2 sets of numbers in the border here, so we can look at these. So let's look at the ones in the left-hand border. To find the mean, we would take 2 plus 3 plus 5 plus 7 plus 7, and that equals 24. And we want to divide that by, we have 5 values. 24 divided by 5, and we get 4.8 for the mean. So that's we'll call it X bar. We'll say it's a sample. So we added them up and got the 24, and we divided by 5 to get 4.8. Okay, let's add up the ones on the set of values, and again we'll call this a sample. 1 plus 2 plus, let's see, 5 plus 5 is 10, plus 7 plus 10, we get 30. So X bar is going to be 30 divided by, this time I think I have 6 values, and so the mean is 5.0. So the mean is found by adding up the values and dividing by the number of values. The median, in order to find the median, you have to first arrange the numbers in order of increasing magnitude. So you can see these I've arranged 2, 3, 5, 7, 7, 1, 2, 5, 5, 7, 10. Okay, so if the number of values is odd, like we have in the left-hand margin, we have 5 values, then the median is the middle one. So our middle one is 5. So that's going to be our median. So if we have an odd number of values, the single middle one is the median. If the number of values is even, like we have over in the right-hand side, then we have to choose the 2 middle ones, and we find the average of those. So it turns out we also have a median of 5 for the one on the right. Now, the mode is the value that occurs most frequently. So if each value occurs only once, then we say there is no mode. So as we look at we have 2 7s, so that's going to be our mode. Here we have 2 5s, so that's going to be our mode. But if we have 2 values, let's say for example, suppose there was another 10, we would have two modes in that case, and that would be bimodal, meaning two modes. If three or more values occur most frequently, then they are all modes, and the data set is called multimodal. Now, in the Math 152 text, they say that anytime you have more than three values occurring most frequently, that it's no mode. So it's just different information, different interpretation. Finally, we have the mid-range, and we find that by adding the high and the low value and then dividing the sum by 2. So on our list over here on the left, 2 plus 7 divided by 2 would be 9 divided by 2. So our mid-range would be 4.5. That's our mid-range. Over here we have a 1 and a 10, so 1 plus 10. That would be 11 divided by 2, so that one would have a mid-range of 5.5. Now, the round-off rule says that we carry one more decimal place than what is present in the original data set. So these two data sets that I use for my examples are all whole numbers. So that means we want to carry our calculations to the nearest tenth, which is what I did. Okay, to the nearest tenth down here. Any calculations are carried out to the nearest tenth. So one more decimal place than the original data values. Later shortcut. So to calculate the mean for a frequency table, what we do is we multiply the frequency times each value and then add those up. And then we add up the number, the frequencies. And so we divide the sum of the frequency times the number by the sum of the frequency, and that gives us x bar. And as I said, I'll do an example of that in the sample problems, and then also I'll show you a calculator shortcut when you're using a frequency table. Now, if you have a class for your value x, in your frequency table, say you have from 0 to 10, what you want to do is you want to take the midpoint and use that as your x. So again, I'll go over some examples in the homework section that I record. Okay, the weighted mean we find by adding up the weights times the values, and then we divide that by the sum of the weights. So what I'm going to do, all right, this goes actually with the problem below. Okay, so weight is 15 for the labs, which counts 100, and 10 for the homework that counts 100. I'm giving you 40%. He has 60 on, this is a fictitious student. 15% for the 80, and 70%, oh, sorry about that, 20% for the 70. So the sum of the frequencies, or the sum of the weights, because these are percentages, all of them are out of 100, so it's sum of the weight is 100. So if you add these 15 plus 10 plus 40 plus 15 plus 20, you'll get 100. Okay. So according to our formula, we want to take 1,500, let's see, 1,000, 2,400, 15 times 80. Helps if I press the 8. I didn't press it hard enough. Okay, 1,200. And then 20 times 70 would be 1,400. So we want to add these up. This will be the way that I calculate your grade. 2,400 plus 1,200 plus 1,400. 7,500. So that's our numerator. And so this student would have, that should be a 0, 7,500 divided by 100 would lead to a 75 or a C. Okay, so remember when you go to calculate your grade that you don't add the points, you want to do a weighted mean. And I do a slightly different version of it, but basically the end result is exactly the same. Okay, now we get to a sample problem. And I want you to complete this sample problem here on this page by finding the mean, the median, the mode, and the mid-range of the salaries for the fictitious company XYZ. And then decide which of those values best represents the center of the data set. So pause the recording right now and use time to calculate the mean, median, mode, and mid-range of the salaries, and then decide which one you think is most representative overall of the salaries for company XYZ. So pause the recording now and then restart it when you have your answers. Okay, I'm assuming at this point that you have done your calculations. And the first thing you have to do is add these up, and I believe it's 420,000. So the mean is 420,000 divided by, we have 10 salaries. So that's a mean of 42,000. Okay, our median, we have 10 values, so it turns out being, we have to add those two and divide by 2, so we're going to get $15,000. Mode is the most frequent. We see 4 of those, so that's 10,000. Mid-range, we're going to take 200 plus 10,000 and divide that by 2, so we get 105,000. Now, the question is, which one is most representative? And my answer is it's the median. And the reason it's the median is because the 200,000 is what we call an outlier. It's an extreme value, very different from most of the other values in the list. So because of that, the outlier, anytime you have an outlier, it's going to affect the mean and it's going to affect the mid-range. They are not resistant to the extreme values. The median is resistant to the extreme values. So anytime you have extreme values, it's a good idea to select your median as your most representative. And notice how easy to kind of, as they say, lie with statistics by presenting the 42,000 or the 105,000 or even the 10,000 as a value that represents the center of this data. So the most representative, the one you want to go with, is the median. Another way you can handle the extreme value is do what you call a 10% trimmed mean. And in the 10% trim mean, you eliminate the top and bottom 10%, and then you calculate using the remaining values. So if I add those up, I get 210,000. Now divided by 8. Since I removed 2 values, and I get a better value for my mean to $26,250. So a 10% trim mean sometimes can handle those outliers if you're interested in calculating that particular mean.